New Zealand and Australia has a road safety problem. Over 1,500 people died in Australia and New Zealand last year. There's a sustainable development goal that sets a target for us of halving the number of global deaths and injuries from road traffic crashes. And our federal governments have set similar targets for harm reduction. Today, I want to talk to you about the different geospatial technologies and data that are being applied to help our governments respond to the road safety pandemic. Roading authorities at all levels spend millions of dollars each year on programs and projects to upgrade road infrastructure and improve driver behaviour. This investment needs to be targeted to the roads that are causing the most trauma, the highest risk roads. The easiest way to assess high risk roads is to look at the crash data. We can analyse that to look at hotspots along corridors or to identify high risk intersections. So here's an example where we've done just that for the TAC. The TAC has a grants program for local police districts to apply for funding for additional enforcement. However, the police don't have the skills to undertake this analysis for themselves. So we helped by undertaking risk analysis of roads with high numbers of speed-related crashes and high numbers of alcohol-related crashes. The police could then use this information to submit their grant applications showing that they were addressing an identified road safety problem. Using crash data is really good when you have good quality crash data and you have a large amount of crash data, so it can be robust. But it's not very good for low volume rural areas where crashes tend to be more random in nature. And it's also very reactive in that you have to wait for the crashes to occur before you respond to the problem. So increasingly we're moving towards proactive ways of assessing road risk. One of these is called the infrastructure risk rating. You can use this to assess roads based on about 10 different attributes, including things like the land use, the speed limit, and the road stereotype. This goes into a formula that returns a risk rating band from low to high. We've done this analysis across all our roads in New Zealand, and it underpins all our road safety programming and projects at a national level. Another risk assessment methodology is the high-risk curves assessment. So you look at a corridor and split it into curves and straights. You can then model acceleration along straights and deceleration through curves. And you can identify high-risk curves where the approach speed is much too high for the curve radius. High-risk curves there, you can see them in red and yellow. So that red curve there, we've looked at all the curves on a large network and calculated that red curves have twice the risk of the yellow or medium risk curves. And those red curves also have 6 times the risk of any other curve on the network. So a very good way of highlighting high-risk curves and then prioritising high-risk corridors for safety treatments, which is, we've done this in New South Wales a couple of years ago. So once you've assessed all your roads and you have a pretty good understanding of where the problems are, you can then use that information to develop a road safety program. And this is what the New Zealand Transport Agency did with this data that we analysed for them. So using this, we were able to develop a theoretical program of safety improvements based on the budget available for those projects targeting the high-risk sites. These projects are a mix of corridor projects and intersection projects. But this is very much a theoretical program. We still have some errors in our data and it hasn't been sense tested on the ground. So the New Zealand Transport Agency took this information out through the pipeline tool. They took it to every local authority in New Zealand as a series of workshops. And through this web tool, they were able to edit corridors, make them shorter and longer. They were able to add and remove projects as well, and to tweak some of the input variables. For example, maybe they were building a cycleway at this intersection site, so the treatment that's suggested is not quite right, and the cost to implement this treatment also needs to be adjusted. It has a built-in submission and approval process to make sure that there's some oversight about the projects that are going into this program, and we're able to track program statistics through this tool. For example, the length of road being treated and the number of intersections being treated. Finally, just want to wrap up on the future opportunities. The really cool one for me is the ability to use LiDAR for different types of applications, such as assessing passing sight lines or extracting roadside hazards. But the true challenge area for us is low to middle income countries where they don't have the crash data and they don't have the road asset data that we do to identify risk. And this is an ongoing challenge that we don't have an answer for yet, but it's certainly become more of a priority recently. And I'll leave it there. Thank you very much.